Hello, I'm Liang Bin from InfuseAI. My topic today is using MLOps to manage machine learning lifecycle. In this talk, I will share about the rise of Software 2.0, machine learning lifecycle, and most importantly, how MLOps can help manage machine learning lifecycle. Then, I will introduce PrimeHub, our MLOps platform. Let's go through the rise of Software 2.0. First of all, let me quote a report from ARC Investment. It says, deep learning, or we call AI, is Software 2.0. It's rapidly growing and consuming the world. In Software 1.0, the software code is written by humans. In the past 15 years, we have invented many tool chains to help us work better on the software development process. We build code editor, IDE, version control system, automated test, software package process, and issue tracking, etc. In Software 2.0, the software code is written by data. We provide lots of data to generate AI models and use our supervision to optimize the result. In the foreseeable future, more important software will be written by AI, like autopilot or drone discovery. Actually, we already use Software 2.0 products every day, like Google Translate, YouTube video recommendation, Tesla Autopilot, or Apple Siri. If you are an engineer in Tesla, you want to write hundreds of thousands of code just in order to detect what's in front of the car. Is it a human, a car, or a dog? Instead, you will say, oh, you should slow down if there is anything before that. Actually, in 2017, Google has transformed their Google Translate from 500,000 lines of C++ code, which is really traditional programming language, is still teaching right now, to 500 lines of data flow code, which is a new machine learning programming language made by themselves. It's a 1,000 performance boost in programmer perspective of view. As I mentioned, in Software 1.0, the code is written by humans based on a functional requirement to generate specific answers. But in Software 2.0, we provide a given programming space and let AI to find the best answer by using data. Data scientists don't want to write a final code directly. They define problem, choose the model structure, and let AI to train and generate the model weight based on the data set. The AI director of Tesla once said on Twitter, hey, great design can write code better than you. I'm sorry. Since the AI models are generated by data, how to create, manage a data set and AI models, and also track the model performance become a really complex work. As you know, there are still many missing pieces in Software 2.0 space, and also lots of needs we don't even know yet. Recently, we are discussing about bias of AI models, explainability, and etc. So just you see in that slide, there's still lots of question mark. This makes me feel very excited. Next, let me introduce the machine learning lifecycle. As a data scientist, if you want to working on data, first you do lots of different experience by using different AI framework or different tools. Once you get the final code, you will train and validate the model. Maybe you will do that many different times. And once you get the final model, you will publish it and transfer to the ML engineer. An engineer will be responsible to build the CI/CD pipeline and develop the model and become an API and transfer to the app engineer. App engineer will warp the API and do the prediction and give a result to user. Yeah, it sounds perfect. What can go wrong? Well, the problem is machine learning development is not a one-time process and require many iterations. Data science teams spend a lot of time to collect, clean, label data, and write machine learning code, train and validate model to get a certified model. Once the model is deployed, the AI project has only just begun. We need to set up monitoring, collect feedback, and keep improving the model. If the model performance degrade, we need to figure out the root cause, like maybe data change, or even the problem space change, and retrain the model to improve the outcome. So actually lots of problems here. As a data scientist, how do I check the different experience outcome? And how do I train and validate the machine learning model if I need more computing resources? How to check the model versioning and the model history? When I deploy it, how do I measure the different deployment and check the API health? When app engineer warp the API into their apps and do the prediction for customer, how do we monitor the outcome, and when should we know, should we retrain the model and to improve the performance? So based on the research, we know only 11% of our organization can put the model into production within a week, and 64% take a month or even longer, which is a really huge problem. And also, 78% of organizations spend more than 15% of their engineer time on development, and it even get worse. The time required to deploy a model increases year by year. It's a huge problem. And next is MLOps and how MLOps can solve. MLOps is not a specific tool or framework. It's a discipline or best practice to collaborate and communication between data scientists and IT professionals while automating and productionize machine learning algorithms. So we can not only run the models in the research lab, but also make it industrialized and meet a service level requirement, so we can deliver to customer and provide a real value. The MLOps is a new field and evolving every month. Just as I mentioned before, there are still many things that need to be discovered. We don't have a fixed standard yet, and people still find new problems and best practice in different angles. Also, major cloud vendors provide their own solution, like Azure, AWS, and Google. They all apply their building block to solve the MLOps problem. We should always keep in mind that MLOps is about breaking the silos between different teams and keep them better collaborate. The goal are to solve the common challenges, like a standardized pipeline, standardized model deployment, and versioning everything. Then, let me introduce PrimeHub. You know, my friend says, the best MLOps infrastructure is the one I don't need to manage. PrimeHub is an end-to-end MLOps platform. We break the silos and let different functional teams work together on the same platform and improve their AI models outcome. We have a community edition on GitHub, and we also provide SDK to interact with data pipeline tools. We focus on machine learning lifecycle and simplify it to train, manage, deploy, and monitor models. It helps data science teams to manage infrastructure, so they don't need to worry about it. By using PrimeHub, they can streamline the MLOps workflow and invite different teams to work together to share the same thought in the project. Let me show you a 1-minute video about PrimeHub.
Log into PrimeHub and we'll see the user portal. All features related to model development are available here. Users can quickly switch between projects to work with the permitted resources set by the administrator. Notice the quota settings changing as we switch groups. We can quickly launch a development environment by selecting the computing resource and building framework. In the Jupyter Notebook, we can train model from our experiments by submitting the notebook as a job or use the schedule if we want to automatically run iterations with different parameter settings. Details of a job are available from the UI, including the configurations, artifacts, and resource consumptions. We can view the model versions and quickly deploy one as new or update an existing deployment. In many cases, the platform automatically fills in the configurations for the users to save the hassle. After the model is deployed, user can monitor the status from the dashboard. The platform also has advanced features for administrators to manage computing resources with.
PrimeHub provides a containerized development environment, so data science team can easily manage the environment across different teams and different projects. We also simplify data management, provide an easy way to set up data governance if necessary. Based on Kubernetes, we also help customers to manage computer resources in both the cloud or on-premise environment, so they can get benefit from features like auto-scaling to reduce the cost. And there's more. We provide PrimeHub apps and SDK to integrate with other tools in the MLOps ecosystem. As I say, the MLOps is a new field and evolves every month. As a startup, we know we can solve every problem ourselves, and that's why we release PrimeHub apps. By integrating popular open source and commercial tools, we can meet customers' growth needs. They can install best-of-breed tools they want and still get benefit of access control, data connection, resource management from PrimeHub. For example, we integrate Label Studio to let data science team to label different kinds of data. They don't need to worry the data connection because we already did it for them. We often integrate a third-party AutoML service to reduce the barrier to adopt AI. Let me show you some tasks like managing computer resources. As user, I want to start a Jupyter Notebook to start some experiment. By using PrimeHub, I can just choose instance type and image, and it can be done in one click. And we also provide a team share files, so people in the same team can share the different files and outcome with others. By leveraging the cloud infrastructure, we can also scale CPU and GPU nodes by request and reduce the cost. Next is submit job from Jupyter Notebook. As a data scientist, I want to run multiple jobs in the cloud. But I don't want to rewrite all the code from Jupyter Notebook to Python code in order to run it. Also, I don't know how to package the code to run across different clusters. By using PrimeHub, data scientists can use our plugin to submit the notebook as a job directly in Jupyter Notebook. They can choose the instance type and choose the hyperparameter and submit. Once it's done, it's running in the background. And you can see the job result, metrics, and download the assets if you want. Another thing is customize the annual stack. As a data scientist, I want to install additional Python packages to use in Notebook and to train the job. But I don't know how to build container image. Or even I know it's really a waste of time for me to build them and to share with teams and set up the configuration, push it to cloud, etc. So in PrimeHub, we provide an easy way to build and extend the container image by using our interface. So people can choose the best image and fill the Python library they want to install, like anti-gravity. Once it's done, it will run a background job to build a container image for you. you can track the building progress, and once it's done, you can choose it in our interface. The next is model management. As a data scientist, I want to work with ML engineer or DevOps to check the model experience and deploy the model to a production. But I don't want to change the code, or I doesn't know how to package a model for deployment. Neither does a DevOps engineer. By using PrimeHub, you can check the model versions, and we provide a deploy button on that. If you click the deploy button, it will ask you if you want to deploy a new model deployment or update the existing one. And we will ask you to choose the model image and deploy it for you. It will done automatically. The next is apps with PrimeHub. As a data scientist, I want to use different data tools such as image labeling, visualization tools, and model management, etc. But I don't want to configure and deploy apps to our infra by our own. And also, it's really hard for me to configure the access control for our team members. So by using PrimeHub apps, I can just choose the apps I want to install and install into our group. And then I can label data in like a data studio and train it after. Yeah, it's what we offer. One of our customers is an AI team from a medical center. They help the emergency room department to manage capacity planning during COVID-19 by making predictions about high-risk disease. They are really good at producing different AI models. But when they create more and more models, it becomes a nightmare for them to manage machine learning lifecycle. Also for PrimeHub, help them to get rid of all the hassles and focus on the true productivity. Before using our product, let's spend 5 or 6 days just in order to communicate the spec and requirement to train and deploy models. Now, they can deploy the model within 1 hour after training. Our clients include finance, healthcare, manufacturer, research institute, and education. We are looking forward to working with you. We provide a way to deploy AI model faster, easier to scale for multiple projects and multiple teams, and use app and SDK to automate and optimize the AI workflow. We are InfuseAI, and let's make AI in production now. Thank you.